in Chapter 7, we're going to be talking about similarities. And to do that, the first thing we need to do is talk about ratios and proportions. So we're going to talk about ratios and how to write them. Then we're going to create proportions using ratios, and then talk about the cross product property. All right, so what's a ratio? A ratio is just combining two numbers, comparing two numbers by division. So like if I ask for the ratio of boys to girls in here, what would you say? Okay, so the ratio of boys, or of girls to boys, is 19 to 6. Now, could I say 6 over 19? Right. You have to keep the order. If I'm comparing girls to boys, girls comes first, boys have to come second. Otherwise, how would anyone know? If I said, what's the ratio of girls to boys, and you said 9 over 16, or 6 over 19, how would anyone know what that meant? So you have to keep the same order that's written in the original question. All right, there's 3 ways to write ratios, like a fraction, which is basically the way we do in math, so we can do math, stop with it. You can write it with a colon, like G colon B, or you can write it 2, and that's generally how you say it. Like if I ask you for the ratio of girls to boys, so I use the 2 version. Okay? All right, and you always want to write ratios in simplest form. Okay, just get in the habit. Do not leave a fraction as 6/8. Just get used to reducing it down to 3/4. Okay, should always ratios always need to be in the lowest terms. All right, one of the most famous ratios, slope. Right, it's the comparison of the movement between points on a line, up and down, compared to left and right. So slope's like a very famous ratio. All right, you can have ratios that are more than 2 numbers. Now you can't write it as a fraction, but you can compare more than 2 things. So for example, if I were comparing, if I wrote a ratio of the side lengths of this rectangle, it would be 3 to 7 to 3 to 7. Okay. So we can use those kinds of ratios to solve problems. Do you remember, well, it's before break, like it was in chapter 6 though, where we did the television, the aspect ratio, the height compared to the width of a television, and we solved for the diagonal. Do you remember doing that? And it was a ratio, it wasn't actual numbers. Okay. Well, if I told you that the ratio of the angle measures of a triangle were 1 to 6 to 13, that means, right, that this angle is 6 times as large as that angle. This one's 13 times as large. Okay? Can you find the measures of those angles? What would we use?
You would like 1x, 6x, and 13x, and then you would equal them to 1.
Exactly. You would say, okay, if this one is 6 times as large as this one, and this is 13 times as large as the first one, we don't know exactly what that original measure is, and whenever we don't know what the measure is, we call it x. So the first angle would be 1x, the second angle would be 6x, and the third angle would be 13x, and we know the inside angles of a triangle give me 180. So I can set it equal to 180. Okay, so add them all up. 1920x equals 180. Divide by 20, so I get x is 9. So this angle would be 9 degrees. This one's going to be 54 degrees. And this one, let's see, 90 plus 27, 117 degrees. How could I check to make sure that was right? Yeah, add them up, make sure they equal 180, right? 9 plus 54, 63. 63, so that's 170, 180. So it works, right? All right, so take a second. Does that make sense to everyone? Yeah? All right, take a second and do this one.
Okay, well, I just did 2x for the first one, 2x for the second one, and 4x for the third one, and added all of them, make sure you equal to 180, and added those up and got 8x equals 180, and then I divided that, and I got 22.5. And then I came back over here and plugged that in to get 45 for the first one, 45 for the second one, and 90 for the third, making it a right triangle because of the 90 degrees.
And by its sides, it says
Isosceles.
good. Isosceles. Because remember, hit that pause button. Let's turn those ratios into proportions. So that's when the actual power comes in. When you take the OGT and the ACD Quality Core, two of your biggest tools that you'll be able to use on multiple problems are right triangles and proportions. Lots of problems, chapters 1 through 12 that we're going to cover this year, a lot of them can be solved with a proportion or with a right triangle. So this is going to be another really important thing. All right, so what is a proportion? A proportion is a statement that says two ratios are equal, and it works both ways. If two ratios are equal, then it's a proportion. If it's a proportion, that means the two ratios are equal. All right, so this says that ratio A over B is equal to ratio C over D. Those two ratios are equal, so that makes it a proportion. All right, and then we're going to talk a little bit about vocabulary. It's not going to affect you much in geometry if you don't know if you don't remember these vocabulary words, but they will show up in pre-calc again. So you need to make sure that you file them away somewhere that you can retrieve them in 2 years. The upper left and lower right, these two numbers here, are called the extremes, and the lower left and upper right, these two here, are called the means. Okay, and the means extremes theorem says that in a proportion, the product of the means equals the product of the extremes. Okay, and that's just, you probably learned it in elementary school as cross products. It means in a proportion, the product of these two is equal to the product of those two. All right, then and if all you're doing is finding a missing number, then you can use the, did you guys learn the Fishy method in elementary, middle school? All right, so if all you're doing is finding just one missing number, you use the Fishy method. Because basically what the Fishy method does is it multiplies these two together. So it says 3 times 56, and then it divides by that one, right? It makes a fish. So basically what you're saying is those two multiplied together equals those two multiplied together, and then to solve it, you divide. So when all you're doing is solving for one variable x in the problem, you can do multiply by there, divide by that, and get this answer. Okay? It's a little different though when the variable appears more than once. Then you do have to write an equation and solve it. So again, using that means extremes or cross products formula, I'm going to multiply across. So what's 2y times 4y? Not 8y. 8y squared, because y times y is y squared, right? So that's 8y squared equals 9 times 8, which is 72. Okay? Now, do I have to get this all on one side, set it equal to 0 and factor? No, because whenever I know that I have to do that when I have a square term and a regular term. But do I have a regular term in this one? No. So I can just solve it just like a regular equation. So I'm going to divide by 8. And that gives me y squared equals 9. And then what? Take the square root. Because undo squaring, you take the square root, and I get y is equal to plus or minus 3. And I really don't know which one. I can't eliminate either of them because there's no context here. Like, I don't know if those can't be negative or positive. I don't know. So I just have to take them both. Right. So y would equal positive or negative 3. Yeah. Okay? And for this one, same thing. I'm going to multiply my means and my extremes. So I get x plus 3 times x plus 3. And that's going to equal 4 times 9, or 36. Okay? What do I do to solve for that? What's the little acronym I use to multiply two binomials? FOIL. Awesome. So I do first, which is x times x, outer, which is x times 3, inner, which is 3 times x, and last, which is 3 times 3. Okay, now this time, let me really quick combine like terms. So I get x squared plus 6x plus 9 equals 36. And this time I have an x squared and an x. So what do I have to do? Move everything to one side, set it equal to 0, and back. Okay, so do that. And again, we don't have a context here, so I can't say which one of these, or if either one can be eliminated. So I just have to say x is equal to negative 9 or 3. I can't choose one or the other. They both do. That would be the whole reason. That's when we solved it. That's how we got it. Okay? Any other questions? That was a good one. Okay. All right. So the other thing you need to know about proportions is that as long as you keep the means and the extremes together, it doesn't matter how you write them. So, like for instance, if I had the girls from period 1 and the boys from period 1 were in the same proportion as the girls from period 9 and the boys from period 9, okay, that would make a ratio. But the same, as long as the means and extremes weren't together, I could say the boys from period 1, where would then the girls from period 9 have to go? Yeah, because these have to go together. So you'd have to put the girls from period 9 here. And then the boys from period 9 would go there. And the girls from period 1 would have to go with it. Does that make sense? So it's the same ratio. You would get the same answers if you were solving for one of the missing pieces. Either way you wrote this, as long as the means and extremes go together. So as long as AD and BC go together, you can write it any way that you want. Does that make sense? Okay? Including as a product. Okay? Because all of these are going to multiply AB together and BC together. Okay? And that seems to come up a lot. Like, I'll write a ratio and someone will raise their hand and say, I wrote it like this. Is that okay? Well, yeah, it's always okay as long as the means and extremes match what I wrote. Does that make sense? Okay. All right. So let's say I'm given 14A is equal to 35B, and I want to find the ratio of what A to B is. Yep. Okay.
Someone said AB equals BC.
Mm-hmm.
If you wrote it in fraction form, would that still be okay, or would we have to do it like with fraction?
No, any of those ways. Yeah, it's fine. All right. So I want to find out what the ratio of A to B is. Okay. Well, if this is it matches this one, right? It's in this form, right? So if A is that number, what's my extreme? What's my other mean there? 14. So where's it going to go? Yeah, down on the lower right, right? Because 14A is going to be the product on the left. And then B times 35. So my ratio of A to B is 35 to 14, or in reduced form would be 5 to 2. Does that make sense? How we figured what that ratio would be? So we're saying that for every 2 of B, we're adding 5 of A. Okay? Okay. Question. You can also solve it this way. You can say, okay, well, 72A is equal to 54B. I'm trying to find the ratio of A to B. So I'm going to try to get A over B on this side. So the first thing I'm going to do is divide by B so that I can get A over B over here. Okay? That would cancel those two, and I'd get 72A over B equals 54. Okay? I'm almost there. But I'd have this 72. It would be A over B if that 72 were gone. So to get rid of that 72, I'm going to divide both sides by 72. Those cancel, and I get A over B equals 54 over 72, which again you told me could reduce down to 3 over 4. So if you like to think of it algebraically, that's another way you can solve it. Like sort of just logically thinking it out, or you can solve it like an equation. Okay? Either way, it's fine. All right, question?